Good morning, everyone. Myself D. Mohit Chaudhary, and today we are going to discuss about a topic called digital communication system. And let's go to intro. Now, what is the digital communication? Now, digital communication is a mode of communication where the information or the thought is encoded digitally as discrete signals and electronically transferred to the recipients. The digital communication is one of the most commonly used modes of communication nowadays. Now, every device, every digital device that we use in our life, like laptop, phone, TV, etc., all of them work through digital communication, because here we need information as in the form of bits or binary digits. So here is the point where digital communication becomes very important. Now, what are some clear examples? Now, manager wanted to meet all his team members at the conference room to discuss their key responsibility areas and areas of expertise. He didn't have time to go to their workstations and invite them individually. Instead, he opted an easier and cheaper mode to communicate his idea. He sent an email marking a CC to all the participants, inviting them for a meeting. This is an example of digital communication where information was sent electronically. So, one way of giving out the information in digital communication. Now, let's explain it. In digital communication, information flows in a digital form, and the source is generally the keyboard of the computer. The general input I/O devices that we use, mouse, keyboard, touchpad, etc., or audio mic, all of them. A single individual is capable of digital communication. That's true. I can digitally communicate with you through this presentation or this video. It also saves the wastage of manpower and is one of the cheapest modes of communication. This is also true because the one person or multiple persons need not travel to other few persons in order to relay the message. And digital communication is also a really quick way to communicate. The information can reach the recipient within a fraction of a second, and an individual no longer has to personally meet other individuals and share his information. And these are the best advantage of digital communication, where it reduces the communication gap between two persons or entities staying afar. Okay, but as we have seen, what are the techniques that we use generally? Digital communication covers a broad area of communication techniques, including a digital transmission, which is the transmission of digital pulses between two or more points in a communication system. This is the one that we said, where information goes in the form of bits, binary digits. Digital radio is the transmitted signal of digital modulated analog carriers between two or more points in the communication system. Here the analog signal is actually modulated in a way that it contains the digital information, and it's transmitted to a farthest destination point. And if we talk about the building blocks of digital communication system, here we have information source and input transducer. This input transducer is something which converts the information into binary pulses, signal pulses, electric pulses, and the source encoder actually convolutes the carrier signal and D signal to form one big stream, and the same with the channel encoder. A digital modulator modulates the carrier signal in such a way that it contains the binary digits information, and it pumps it into a channel, and all over through the channel. When it travels and reaches the destination, the digital demodulator decodes the signal received, and the demodulated signal is separated into the information signal. The information signal is again decoded at the channel decoder and again at the source decoder, and at output transducer we get the output signal means the digital data which the user at the other side wanted to send us. Okay, Now we will discuss it very deeply now, one by one block. Here the input source and input transducer. The source of information can be analog or digital, like analog audio or video signal, or digital like teletype signal. And the source encoder, the signal produced by source is converted into digital signal consisting of zeros and ones. For this finite source encoder, we should like to use as few binary digits as possible to represent the signal. In such a way, this efficient representation of the source output results in little or no redundancy. This sequence of binary digits is called information sequence. Now, the source encoding or data compression is the process of efficiently converting the output of analog or digital source into a sequence of binary digits, and it is known as source encoding. Now, the channel encoder. The information sequence is passed through the channel encoder. The purpose of the channel encoder is to introduce in a controlled manner some redundancy in binary information sequence that can be used at the receiver to overcome the effects of noise and interference encountered in the transmission on the signal through the channel. For example, let's take k bits of the information sequence that map the k bits to unique n bit sequence called code word. The amount of redundancy introduced is measured by the ratio n by k, and the reciprocal of this ratio k by n is known as the rate of code or code rate. This is the function of the channel encoder. Now, the rest of the blocks. The digital modulator is the block where the binary sequence is passed to a digital and it will get converted into a sequence of electric signals, so which can be transmitted on the channel. The digital modulator maps the binary sequences into signal waveforms. For example, if we represent 1 by sin x and 0 by cos x, then we will transmit sin x for 1 and cos x for 0. So that's the way the digital modulation is done. And if you talk about the channel, the communication channel is the physical medium that is used for transmitting signals from transmitter to receiver. This channel can be anything like air, electric cable, etc., or fiber optic cable, anything. The digital demodulator is the device. It processes the channel corrupted transmitted waveform and reduces the waveform to sequence of numbers that represents estimates of the transmitted data symbols. Now, the channel decoder. When the input sequence of numbers and pass through the channel decoder attempts to reconstruct the original information sequence from the knowledge of the code used by the channel encoder and the redundancy contained in the received data. The average probability of a bit error at the output of the decoder is measure of the performance of the demodulator and decoder combination. And the source decoder, it tries to decode the sequence from the knowledge of the encoding algorithm, and which results in the approximate replica of the input transmitter at the end. And finally the output transducer. Finally, we get the desired signal in desired format or analog, whether it is analog or digital. Now, channels for digital communication. The modulation and coding used in a digital communication system depend on the characteristics of the channel. The two main characteristics of the channel are bandwidth and power. In addition, the other characteristics are whether the channel is linear or non-linear and how free the channel is free from the external inference. The 5 channels are considered in digital communication, namely the telephone channels, the coaxial cables, and the optical fiber cables, and microwave, radio, and satellite channels. Now, causes of signal loss. The main factors of degradation of a signal in a digital communication are a loss in signal to noise ratio and signal distortion caused by ISI, distance. and the distance also affects. Now, uh, loss in signal to noise ratio, the SNR can be degraded into two ways, though through decrease of desired signal power through increase of noise power. And band limiting loss is the use of filters in the transmitter to avoid interfering with other channel, reduces the amount of energy resulting in signal loss. The intersymbol interference ISI, filtering through the system, the received pulses overlap one another. The tail of one pulse smear into the adjacent symbol interval, causing the loss of data in digital communication. Next, the distance is a great chance for signal distortion, as when the distance is large we use repeaters to amplify the signal. It amplifies the noise. So these are the things that we need to consider as far as our topic of digital communication is concerned. And thank you for being there.